Kevin?
What was that last year?
Bethany, there's a homework check.
She literally went from unstable.
Yes, so Bob,
Make
make sure you show me your homework when you return on Monday.
Oh, that's a cool. But at least you know.
Change your status.
I don't know, what's she thinking?
13B. What do we have to do in this problem?
Find the
It
t
says
squared y.
Are you good? We went over this.
No, but then I didn't get like.
All you have to do is take derivatives.
I did. No, I did 13A though.
Yeah, I got one.
Well, 13A is what?
Find the derivative.
Well, you have to find first derivative before you find the
I
second.
did.
derivative.
Oh wait, I got cosine square.
So, to compute dy dx, that is simply dy dt over dt dx dt. So, dy dt, Pascal, is?
Secant squared. No wait, dy? Oh, what's it called? Secant square. Oh, secant tangent.
And dx dt
Secant squared.
is secant squared. And so that simplifies to tangent over secant,
Which is sine.
which is equal to sine.
Got that far. And then.
So now, to find the second derivative of y with respect to x, remember, that is the derivative of y prime with respect to t over dx dt, correct?
Yeah.
Because you're taking the derivative with respect to x, not t. So, this is the first derivative. What's the derivative? With respect to t?
Cosine t.
Cosine t. And then you have to divide that by dx dt, which we did right there. Secant squared t. So isn't that the same thing as
Cosine.
cosine cubed?
Oh.
Why? It's very mechanical.
Oh. So you find the derivative of the.
Of the first derivative.
Okay. That's.
And then you have to divide by another dx dt. Because but
My dad likes.
That's what I did wrong. I just use.
even though we did this in the lecture,
No, I
it
know.
has multiple examples in the book.
Yeah. I just put in sine cubes.
Oh, I don't want to disrupt your paper reading, Nomura. Nomura, I don't want to disrupt your paper reading.
Sorry, I didn't read anything yet.
Yes.
After I wrote that recommendation on one-day notice for the Hawaii community.
Wait, what? Oh, you applied for that? Wait, that wasn't one day, was it?
He keeps bringing that up with me.
Wait, no, that literally. Wait, no, mine wasn't one day. It was just without notice. Or like the email just said.
Hawaii
and I
Community
didn't ask
Foundation
you.
Scholarship. That's the
Can
one.
I borrow?
Yeah, but I didn't ask you one day in advance. I just didn't ask you.
Oh, that's different then. Continue. Oh,
That's a video.
I felt something hit my eye. I hope it wasn't your eye.
I can't do the math homework anymore.
Was it your eye?
No.
Wait, you watched me get up there.
Good, I didn't get germs on the top.
Oh god, why do I keep asking?
Mr. Bar,
Wait,
Mr. Bar, can I borrow your book?
actually, I already knew that one too.
Wait, I'm so stupid.
Everybody watch the video.
What kind of limits are these? It says, sketch the curve over the given. This is exactly what we did in PCH in the review in the beginning of the year. I don't like this 1.5 to 4.5 business. I really don't like it.
Oh, I just made
Identify the requested point. Justify that you have found the requested point. Okay, well, we're not going to do that part. Remember I told you don't.
This
don't-
part. I think they meant like 3 halves of that.
Oh, like from 3 pi over 2. Oh, you think they meant from 3 pi over 2 to 9 pi over 2.
Because that's what it is in the answer too.
Oh, that's what that would make more sense because who knows what sine of 1.5 is?
Exactly, that's how I
Wait, let me try.
Why would they do that?
Wait, 57.3 degrees is 1 radian. So 1.5, think what is half of that? 28.65. So that would be 85, so pretty much 86 degrees. 86 degrees of the, so sine is the y coordinate of the point, 0.97.
What?
We're trying to figure out the sine of 1.5 radians.
Why?
You did.
I did it for fun.
Nah.
0.997.
Oh!
Mr.
Next
Park,
time,
remember when
next
you
time.
used to,
I'm losing it.
Mr. Park, remember when you used to steal from Jack in the Box for fun?
I don't remember any of that. Okay, to eliminate the parameter when you have trig functions, you're going to use identity. So cosine 2t, which identity am I using here, Kimura? The cosine 2t, there's 3 identities, but since this one has a sign in it, I'm going to use
2 cosine squared.
this one has a sign in it.
Oh, 1 minus 2 sine squared.
Exactly. So this is what we got so far. Y equal 1 minus 2. And if you take this equation and solve for sine, you get x over 2. So therefore, what is sine squared? If sine is x over 2, here, let's write it out. If sine t is x over 2, what is sine squared? Squaring both sides of the equation. X squared over 4. So you got y equal 1 minus x squared over, this is kind of ugly, their equation. I don't like it. Okay, so this is what we did in PCH last year. We draw the graph using a dotted line. So the y-intercept is 1. What are the x-intercepts? X-intercepts, follow. Read it off your paper.
It is root 2.
Plus or minus, right?
Yeah.
So plus or minus 1.4. So this is what the graph looks like. But then now you have to figure out how the particle is traveling on this. So I guess they want you to figure it out from 3 pi over 2. So this is what we did last year in PCH. You guys remember this?
Yeah.
So 3 pi over 2 all the way to 9 pi. Why do we need to go to 9 pi over 2? We'll just do it.
That's what it said.
I think if we plot a point every pi over 2, we should be fine. So what is that? 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2. And then you fill in the chart. Okay, so you go back to your original equations, and then you plug in the number. We're not using any stinking calculator, that's why. I'll do the first one. If you plug in 3 pi over 2, you're going to get -2 and 3 by -1. So your initial position is right here. This is the initial position of the particle. And then where does it go from there? We'll fill in the chart. Cho, 2 pi. Read it off the paper.
0 and 1.
Yes, 0, 1. So all the particles there. 5 pi over 2, part. 5 pi over 2.
Oh, that's 0. Oh, you mean sorry.
No.
That's -2. No, wait. Sorry, 2.
Okay, 2.
Oh.
Okay, I'll give you a hint. Instead,
-1.
if you have a hard time plugging 5 pi over 2, yeah, it's -1. Why not, once you find the x coordinate, why not just plug the x coordinate in here to get the y coordinate? Because these equations are all related, right? Whatever. So 2, -1, 3 pi, ha. What was that? 0, 1. Anyway, we kind of know what's going to happen already, right? Can you see? We don't even have to fill in the chart. The particle starts here, goes like this. And it just keeps going back and forth.
What is he doing?
That's the path traced out by the particle. Okay, now what else do we have to find in this problem? This is number 21. It says, identify 21, the highest point. Now the highest point over here is when the slope of the tangent line is 0. So we want dy dx to be 0, right? Because dy dx is the slope. So how do I compute dy dx? That would be dy dt over dx dt, which is, what is dy dt? Zhao, dy dt.
That's -2 sine 2t.
Yes. And dx dt is, Boisvert?
2 cosine.
Okay, and if we we simplify that, that's the 2's cancel out, so you get negative 2 sine t cosine t using the double angle identity over cosine t, swing, equals negative 2 sine t. So this is dx dt. We want to know when that is equal to 0. So when is this equal to 0? Well, when sine t equals 0. And when would that be over this interval here?
2 pi d5
2 pi, 3 pi, and 4 pi. Because think about it, it starts here, goes like this, right when it reaches there, this is 2 pi, right here. That's the highest point, right? And then it's going to go down, and it's going to come back up. Now we're at 3 pi again, and then it's going to go 4 pi. 3 times it's going to hit that maximum point. Yeah.
How come it doesn't have like the answers for 17?
I don't know.
Just
Are you using my teacher's edition?
I asked him how to use your book.
This one.
Oh, picture.
You don't grab a book with the answers in it?
Why?
I don't want to use the book.
Oh,
Yeah, you can use it, I don't care.
it doesn't have the answer. I have to go look in the
I know, sometimes, yeah, the book is weird. Just like Davis's, where's Davis? He's not even here. Davis's book had
He
all
skipped
the,
class.
he had all the answers in it for some reason.
Really for that one section?
Yeah,
Should have bought that one.
23.
Wait.
Well, just for that one chapter or section.
Wait, is there a way to buy the teacher's edition?
I'm sure you can somewhere.
All right.
I think it's too late for that now.
2
Well,
plus
I'm looking for the future.
y
For
equals
other
negative.
books.
Now it says, find the points at which the tangent line to the curve is horizontal and vertical. Come on! Okay, before we even start this problem, I hope you guys are well versed at this already, so you guys can just look at this and you know what the graph is going to be. Woo! Just looking at this, what is the graph going to be? A, line. Okay, forget the ABC. Line, parabola, circle, ellipse, hyperbola, none of the above. Poja. How do you know? Yeah, because you get sine and cosine there. You square both ends as a circle. Because look, x minus 2 equal, you isolate the cosine,
Wait, there was no 20.
isolate the sine, square both sides.
Because apparently there was no 23. And you said
It's on the board!
There's no
So,
23.
okay, well let's at least just do this part then. Okay? So if you add the equations,
Wait, 25? No, I shouted 25.
if you add the two equations, boom, it's a circle.
Easy.
Yeah. Anyway, once you have a circle, look, you know why I took it up? Because once you have a circle, where are the tangent lines horizontal? And where are the tangent lines vertical? These 2 points right there, right? So it's like child's play. It's not like when you have like an odd looking curve.
Now it changes. Did you refresh it before? I did that last night, but I had 23.
Don't worry, after.
Oh, you took out so many problems.
I told you!
Does anybody have
Oh,
I told you.
I'm trying to make your homework load less, boy bear.
It did load. Sorry.
Did anyone take
What's sorry?
pictures?
Wait,
What?
the part
did?
that those the
Could
problems
you
that you're
airdrop
gonna
it to
have,
Cup,
like,
please?
those the problems that you're gonna keep and not touch.
I'm not gonna touch unless. Oh, you mean for the future assignment?
No, but these like.
No, I think I touched them all already. That doesn't sound right.
Mr. Park, I think you
Like, is that the problems for like the next year?
Yeah, I'm not gonna change. No, I changed them already.
Okay.
They are revised unless
I just wanna
there's a
see.
second revision.
Thank you.
You know how that goes.
Mr. Park, I think you did touch my eye.
I told you I felt something on the tip of the chalk. Yeah, like eye tissue. 33.
It's not that funny.
It's not that funny.
Wait, but okay, wait, but like for like 23, that kind of problem, and they ask,
When you have vertical and horizontal tangents.
yeah, you just said the first derivative.
So yeah, you set the first derivative equal to 0, and then for vertical, you make, where is it undefined?
Do we need to take the derivative if it's obvious?
I'm not gonna give you an obvious one, and I'm sure AP exam, they're not gonna give you an obvious one either.
That's too bad.
Why would they give you an obvious one? Okay, now here is one that, this graph is kind of bizarre. I think. Okay, what are we asked to find? Look, this is just the length of the curve. This is simple.
Length of the curve equation.
Okay, what is the length of the curve? It's the integral from 0 to 1 of the square root of dx dt squared plus dy dt squared dt. Right? Didn't we derive this equation last time?
Yeah.
Okay, so what is dx dt? Here's x. What is dx dt?
T squared.
T squared. What is dy dt? T. So this is the integral from 0 to 1 of the square root of t to the 4th plus t to the squared dt. Now the question is, can we compute this without a calculator?
No.
Yes! Somebody give me a preview. Kuromaru.
Oh, factor out.
Okay, you take out, okay, this is obviously t squared times t squared plus 1, right? The t squared comes out of the radical as absolute value of t, but between 0 and 1 it's positive, so no need absolute value. No, this is BC. Sometimes it is absolute value. What if it went from negative 1 to 1? Then you gotta make two separate
No,
integrals.
but you knew that.
Oh, okay.
Yeah, but since from 0 to 1 it's always positive, okay, now how do I do this integral, Kuromaru? Product rule!
No.
Wait, I want to climb off the window. Product rule! That's for finding
Somebody
derivatives.
said you
We
did
are
that.
computing an antiderivative.
Wait, you climbed up the window?
Yeah, somebody said you climbed down.
No, I was trying to.
Wait, which window? It's on?
You substitute.
No, because AP, they did something really stupid and they just couldn't take it already.
Oh yeah, you're You said
Oh, your voice sounded like a girl there. So U equals T squared plus 1. Du sounded like hot, in fact. 2T TT. Yes, you sub.
Oh, really? Oh, yeah. That's right. Nancy.
We're supposed to be experts in integrals. And those of you coming to multivariable calculus next year, the very first chapter is integral review.
Okay, that's
Okay, so what have we got here? Square root of u. What do I substitute for dt dt? Du over 2. And what are my new limits of integration? Miwa. The more I saw you yawning. You think teachers don't notice these things? Miwa, what are from 1 to 2. So we got 1/2, the antiderivative of u to the half is u to the 3/2 with the 2/3 in the front. From 1 to 2, factor out the constant, swing. You got 1/3, and what is 2 to the 3/2 power? 2 root 2 minus 1. Bam, that's the length of the curve. Now, if you're too chicken, you can just write 2 to the 3/2 power. What's up, people? I don't want to.
Can?
Yeah, 2 to the 3/2, I think that would. Yeah, but you know when you take the multiple choice part, you gotta be able to pick out the answer, you know.
No, then what about in
You might have 2 to the 3/2, but you better know, like, they're gonna have several answers.
what about your
Oh, if you put 2 to the 3/2, I will give you that. Okay, let's move on, people. This video is getting long. Lum is yawning like no more. 39. Find the area of the shaded region! We went over it! Yarr! What is this? What is 39? Does it refer to something?
No, that's just a graph.
No, but they have to give you an equation. Obviously, we have to go back to problem something.
It's on the
No,
bottom
it's-
left corner
it's
of the
right
page.
No, X is.
The bottom left corner?
Like, look.
Wait, why isn't it A right there?
Where?
Bottom left corner.
It says exercises 39 and 40 refer to the region bounded by.
I don't have that in my book.
X-axis
On the left?
and one.
The bottom left?
I don't have a bottom. Oh, right there!
It's okay.
This is the cycloid!
He's getting old.
What the heck is, what the
Whoa.
Oh no.
Strike 2 for that.
Oh
You're not believing it.
These are the equations of the cycloid right here. Y equals, the one example I did last time was when A is equal to 1. Yeah, we still gotta have a lesson, and we gotta go over the test, which we badly need to do. Okay, you know what? I'm just gonna set up the integral for you guys, and then you guys are gonna do it. Now the cycloid looks like this from 0 to 2 pi, right? It goes like this. Yeah. We want to compute this area. So what you do is you make a rectangle of infinitesimal width. Okay, what is the length of that rectangle?
Yeah.
No, the length. The height is the height. The height of the rectangle is
Why?
y, and the infinitesimal width is
dy.
dx. Even AB, I trained them to do it. Vertical rectangle is dx. Horizontal rectangle is dy. Why?
There's an I. There's an I.
Let's try.
You add up all of these rectangles from. Now, if you were doing the integral in terms of x, you would go from 0 to. What is the x? What is the x coordinate there? No, that's not that. The limits of integration for t would be 0 to 2 pi. But if you're doing the integral in terms of x, what would it be? It would be the x coordinate here to the x coordinate there. 0 to. What is the x coordinate
2a
right
pi.
there?
2a.
2 pi a.
Oh my god.
Just plug it in here. Plug in 2 pi.
Okay, what is the a
And-
though?
That's
It's
just
a
a
constant.
constant. It's a constant.
Like what is
Like
it?
when I did the problem for you last time, a was 1, but a doesn't always have to be 1. It's gonna just change it because up here was 1, but then now it's gonna be a, yeah?
2a.
And then this was 2 pi before, but now it's 2 pi a. That's the only difference.
So the top is there have to be the same.
Oh, it's 2a?
Yeah.
You're right. It's 2a. It's the diameter of a circle. Anyway, but we want to do this integral parametrically. So remember what I told you last time? You think of dx dt. I mean, I gave it away. Dx is the same thing as dx dt times dt, because you're going to do the integral in terms of t. See, because the dt's cancel, you get dx. So now, if you're going to do this integral in terms of t, what do I substitute for y? Right there. A times 1 minus cosine t. What do I substitute for dx dt, which is the derivative of this? Show the constant on the side, and you get 1 minus cosine t. Come on! This is almost exactly like the thing we did before. dt, and then we're going to add up all of these rectangles, but we're doing it in terms of t. So what is the t value here and there? I'll answer the question. 0 to 2 pi, and then you can throw the a squared on the outside. Here, I'll go one more step then. A squared, integral from 0 to 2 pi. And then you have 1 minus cosine t quantity t squared. How do I do that? I'll give you a hint. You want to multiply it out, which is fine, or do you want to use a trig identity?
Trig identity.
1 minus cosine t. I forget how I did it last time already. Where have I seen 1 minus cosine t in a trig identity before? Cosine theta over 2 is plus or minus the square, oh, the sine. This is sine, sorry. Sine of theta over 2 is 1 minus cosine theta all over 2, correct?
Sir.
There! There she blows!
What?
You know when you see a whale?
No.
There she blows! And then you get out the harpoon.
Wow.
Well, if you read Moby Dick.
Oh, did you
Eagle- no.
Such a long book.
I thought Moby
But I heard about it.
Oh.
So tell me, what is 1 minus, oh, you know what? It's gonna come out ugly anyway, because you gotta square both sides and you're gonna get sine to the 4. So let's not do this. Let's, never mind what I said. Just multiply it out. You guys can take it from there. Yeah. And then finally, number 50. Shh. No, because the time interval goes from 0 to 4 pi, yeah. Time interval. And then finally, number 50. Good thing today's lesson is easy.
Is it?
It's interesting too, especially for those of you who took physics,
Oh, I took physics. Oh, show.
which is everybody, right?
Oh, show.
Oh yeah, I forgot. Here is the curve. The x equals 6. Cho, are you taking physics next year?
Oh, yeah.
Is it required? Is physics a required class?
Yes.
It is?
You have to go to.
You have to take one of each. Is that how it works?
Yeah, biochem phys.
You don't know. That's just strongly recommended. Oh, you
But
have to.
are you kidding me? The length of curve? Come on! How do you find the length of curve? Integral from 0 to 2 pi, the square root of dx dt squares plus dy dt squared dt. So all you gotta do is take the derivative of that and put it there. Take the derivative of this, put it there, and pick out the answer. Okay, what's the derivative of the first one? Nomura.
6 cosine t minus 21 cosine 7t.
Okay, and what's the derivative of the second one? Nomura.
What the heck?
I'm gonna pay for that yawn.
Negative 6 sine t plus 21 sine.
That is correct. And then just pick out the answers. What did they do? Multiply it up? No! It's just like that! Okay, you guys are scaring me.
Why?
Because all you have to do is take derivatives, man. And do you notice that what the graph looks like? Look, you guys see the graph? Look, it's like, oh,
It's a chain.
curly Q-ish. Curly Q-ish.
They gave the graph.
Yeah, they gave the graph in the book. It looks like this. Something like, I don't know, something like that. See, curly Q-ish.
Yeah, just like I should say.
Okay, today we learn about vector functions. Now, when we parametric equations, they give you the position of a particle traveling in the xy plane. So all we're going to do this year is we have a particle moving in the Cartesian plane. Next year, though, multivariable calculus, whether you're taking it here or in college, then you're going to do it in space. So you're just going to have a z component to it. It's the same thing, except a little bit more complicated. So, what if you have parametric equations like this? Cosine t, y equals sine t. We'll do an easy one. All right. Can you tell me what the rectangular equation is? If you square both sides. You get x squared plus y squared equal 1, which is a circle. Circle. So, boop, 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 boop. Na, 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 na. So, if we say t is greater than or equal to 0, the particle starts here, right? If you plug 0 in here, initial position 1, 0. Which way is it going around? Counterclockwise or clockwise?
Counterclockwise.
How do you know? Because if you plug in pi over 2, you get 0, 1. Yeah, so the particle starts here and it goes this. So what we have here is uniform circular motion. And those of you who took physics, Cho, next year you can dominate. Because you have the tool of calculus, that's why. All the other blokes in the class, all they're gonna do is memorize formulas and just try to like
The other what?
manipulate the equations. But you have the gift of calculus. No, for real. Because they don't know that the derivative of position is velocity and the derivative of velocity is acceleration, so you can just dominate that thing.
The thing is, it's object based.
I know, but yeah. Okay, so what we can do is we can define a position vector. Now, what does the book use for position vector?
R.
R. Okay, that makes sense. So the position vector then is cosine t sine t. See, it's like it's basically the parametric equations because this gives you the position vector. Now, what the heck is a position vector? So if we have a particle traveling in the plane like this, when t is 0, isn't this where the particle is? The position vector is a vector that goes from the origin to that point. That is called the position vector. It just tells you the position of the particle. And for those of you who forgot how to componentize vectors, do we need a quick review?
Yes.
Like how to add and subtract?
Yes.
Are you serious? Okay, let's say you have a vector v. Let's just go. Here's the point A, 2, 1. Here's point B, which is 6, 4. How do you componentize vector AB? How do you componentize it? Okay, so here, a vector that goes from A to B, right? Because look, the tail of the vector is here, the head is over there.
B minus A.
Yeah, if you go head minus tail. In fact, I was looking at the book. The book calls it the head minus tail method. That's
Is it even?
Why do we need a method for that?
Yeah,
How
it's
about
not
just
even a
common
method.
sense, just go head minus tail. So what is 6 minus 2? 4. What is 4 minus 1? 3. That's how you componentize a vector. We call this the x component and that's the y component. In other words, to get from this point to this point, you gotta go 4 right and 3 up. That's you guys in physics know how to componentize vectors, right? And let's say you have another vector, CD, I'm just gonna make up something, -1, 2. So if you have two vectors that are componentized, how do you add them together? Like this. You guys remember?
X and Y.
Yeah, you just add the x components, add the y components, finished.
Oh, you just.
Yeah, how do you multiply a vector by a constant? Like if this is vector CD, what is 3 times vector CD? What do? You multiply each component by 3, so you're gonna get -3, 6. And then, what if they ask you this? What does this mean? What is that? And don't say absolute value. That's the magnitude of the vector, which is the length of the vector. So if you have a vector with x component 4 and y component 3, how do I find the length of that vector?
Ooh,
You use the Pythagorean theorem. It's basically the square root of this component squared plus this component squared, which of course is 5. Okay, that's the basics. And in this class, we are not going to do dot product and cross product. So it's just addition, subtraction, multiplied by a constant. So this is the position vector. Now, if you have a position vector, how do you think of going to get the velocity vector? You take the derivative, right? Because velocity is the derivative of position. So just take the derivative of each component. What's the derivative of cosine t? Negative sine t, and then cosine t. This is called your velocity vector. And then if you know the velocity vector, how do you compute the acceleration vector? You take the derivative again. So what is that going to be? Negative cosine t, negative sine t. Correct?
Yeah.
So at each point, you can figure out what the position vector is, what the velocity vector is, and what the acceleration vector is. So why don't we do one right here? At t equal pi over 2, what is the position vector? Plug in pi over 2, 0, comma 1. In other words, this is the position vector there. It means it has an x component of 0 and a y component of 1. Basically, it tells you the position. Velocity vector. So here's the velocity vector. When t is pi over 2, what is the velocity vector? Plug in pi over 2. -1, 0. So if you were to draw that, it would look like this, right? It has an x component of -1 and a y component of 0. Does that confirm what you learned in physics of uniform circular motion?
Yeah.
When you have uniform circular motion, the velocity is always tangent to the graph, right? You guys learned that? And then finally, acceleration vector. When t is pi over 2, plug it in, what do you get? Plug in pi over 2. 0, -1. So, in other words, at t equal pi over 2, the acceleration vector looks like that. Notice that it's centripetally inward. That's exactly what we learned in physics. But see, that's the thing is, when you take physics and other blokes don't know calculus, Cho, I'm looking at you. All you gotta do is take derivatives, and you don't even have to know like it's tangent and then it's centripetally inward. All you gotta do is take the derivatives.
It's not like cheating though.
No, it's not cheating. It's using tools. You just have better tools than all the other blokes. The other blokes have like they have ice picks and screwdrivers. You have like a jackhammer and a
Flamethrower?
flamethrower. And what's the thing that that scoops the dirt out of the ground? You have a tractor. Tractor.
A shovel.
No, the other people have shovels. You have
No, there's
a tractor.
it's called like it's like a ends of a Y. Like a
Trailery.
Trailer.
no.
A claw thing.
We're digressing.
Okay, now does everybody understand the difference between velocity and speed?
Yes.
Okay, now when t is pi over 2, this is the velocity vector. What if I were to ask you at t equal pi over 2, what is the speed of the particle?
Pythagorean.
And you have the absolute value.
Speed is simply The absolute, well, it's not the absolute value, it's the magnitude of the velocity vector. So if this is the velocity vector, what is the speed? It's pretty easy. It's the square root of that squared plus that squared. 1. And that's a very important concept in physics. You gotta know the difference between speed and velocity. Well, when you take the BC exam, you gotta know that too. And then what about length of curve? How do you find the length of curve? Well, we already did it, right? We already did it. If a graph is given parametrically, right here, so it's when you're given a position vector, it's like this is x and this is y. How do you find the length of curve? It's the square root of dx dt squared plus dy dt squared dt, and then you just add it up from t1 to t2. That's how you find the length of curve, because you're going to do that in tonight's homework too. But notice that dx dt is simply the velocity, the x component. This is the x component of the velocity. This is the y component of the velocity. That's how you find the total distance traveled. So tonight's homework is pretty darn easy. I think you guys can do it already. Except the book defines one thing. Can I look at your book? This is what your book. You're not even on the right section.
Oh.
Your book defines this, the direction of motion. But see, it doesn't matter. Whatever, like uniform circular motion, the direction of motion is always going to be tangent to the circle. Well, it doesn't matter what the graph is. To find the direction of motion, it's always going to be it's tangent. That's the velocity vector. The velocity vector is always going to be tangent to the curve because it's a derivative. It makes sense, right? So the book defines it as the velocity vector over the length of the velocity vector. Okay, we did this in PCH last year. What is that? What happens when you have a vector and you divide it by its length? Okay, here, I'll give you an example. Here's a vector. What is the length of that vector?
5.
It's 5. What would happen if I divided this by 5? You would get 4/5, 3/5. The length is 1. What do we call it? You take engineering and physics, you gotta know, it's called a unit vector. Unit vector. A unit vector is a vector simply that has a length of 1. So the direction, they call it the direction of motion. I don't think you need that, you just need this. The direction of motion is in the direction of the velocity vector. That's what you gotta know. Except when you divide it by the length of the vector, you basically get a vector of length 1. But who cares if it's like, has a length of 5 or a length of 1? Right, it's still pointing in that direction. Nobody cares. No, well, they might ask, I don't know, you don't know what they're gonna ask you on the AP exam.
So you're just looking at the sun.
No, you're just looking at the velocity. So the direction of motion of the particle is the direction of the velocity vector. That's what it is. But they choose to divide it by the length of the velocity vector, which just gives you a unit vector that goes in the same direction.
So the direction of motion is a vector.
Yes, direction of motion is a vector that points in the direction of the velocity.
Why do you need that?
Well, you know, when you do the problems tonight, they're going to ask you what's the direction of motion. Then just tell them, say the velocity vector.
And that's what you need.
Yeah. Okay, oh gosh, we're in trouble. Okay, let me pass back the test.
Oh, that's.
We need to turn off the camera then.